the opportunity to make this presentation. The presentation, mainly the main issue we have in this, let's say, session is how with the ALEMO machinery finally is the big reduction in CO2 footprint for the product. But this reduction of CO2 footprint is finally also a reduction of cost of the product, because as much as we reduce the footprint of one product, so directly we reduce the cost of the product, especially in this process engineered materials. This result is coming from 25 years of work. At the beginning as a foam producer. My name is, I did not present myself, my name is Andrea Sirk. I'm an engineer, chemical engineer, graduated in chemical engineering. And I started, let's say, with foam in year 2000, first as a producer of foam. But then I have been, let's say, modifying continuously the machines, making upgrades, basically making things to reduce the cost of the product, to reduce the downtimes, to reduce the density, to make better product, and so on. But finally I discovered I liked much more the, let's say, machines, modification and doing and so on, than the production by itself, because production you receive call at 2 o'clock in the morning and not so nice. I prefer very much machinery. And then we started to make this work, and actually I was, one day I was provoked by one doctor in medicine that I'm in plastic, that plastic is something dirty, that plastic is something that is making big CO2 footprint and so on. And I started to calculate how is the CO2 footprint with factory, well working with ALEMO machinery or other machinery. And finally, the result was that for each kilogram of foam produced, there is 1 kilogram of CO2 footprint, let's say, less for the world. And this is actually also direct saving in product itself. And yes, this is CO2. This is finally circulation now of reduction of materials, reduction of energy consumption, machine efficiency, and again and again. No? This is now. And finally, in direct calculation, I will show how for 1 pound of foam, the first reduction of 0.8 pound of CO2 can be calculated. Then we will see also how the remaining 0.2 kilograms, or from where the remaining 0.2 kilograms are coming. This is the Excel calculation. There are some 20, let's say, keys with open calculations for whom is interested in. Comparing a standard production with one actual, let's say, production with ALEMO machinery. And I was first astonished about these results. And if somebody is interested and finds something that is wrong, I will be grateful, let's say, to find something wrong in this calculation. Whoever wants to look this calculation, I'm open to this. Obviously not here because we have no time. This on the factory, let's say this is based on the factory making 3 kiloton of foam. And finally, we can see direct reduction of 2.5 kilotons of CO2. Very strong issue, now seems very strong issue, but it seems. And how or from where are these big savings achieved? First point, for example, is on the very light protective foam. This I bring also here are our catalogs and catalogs of our customer. They produce in 126 inches width, from 116 to 126 with same die, no die changes, never. They keep the same die lips for 1 year with special treatments and so on. No die change lips. And just changing on the mandrel or with the variable mandrel and slitting the foam, all the widths are achieved without any stop of the machine. This is a huge reduction in the cost of the product, because you have no starts, no stops, no die changes, much less slitting, because here you have the slitting on 126 inches or 116, depends how you, but you have only one side trimming. If you produce on 48 inches or whatever, you have much more side trimming. No, all this is coming. And the product itself. No, this is the catalog of our customer in Italy. They are producing this 0.5 millimeter. This is, I have to see, 0. Very light foam. This is 11 grams per square meter. This is, you see, very light foam. There are samples here. To my best knowledge, I hope I am wrong, but to my best knowledge, there is no foam like this in United States. And this foam is making the job 100%. Because if you have to protect one, let's say, one screen of television or computer or whatever, this foam is making the job 100%. But finally is half weight per square meter if compared with what I find of the best production here in the United States. And this is a lot of CO2 or a lot of material or a lot of cost can be put in this, let's say, the content is the same. Then, for sure, this is maybe in United States not so important because the cost of energy is low, but in Europe, in some parts of Europe, this is quite important, using all components that have very low energy consumption. For example, we use variable reluctancy main motors that have the same efficiency, that have almost flat curve on the RPMs, while normal motors, have curve like this. But extruder motor is almost never used on the standard RPMs. Is even lower or higher, but not on the standard RPMs, out of the top efficiency. But this maybe for US is not so important. And this is another very important, but all this because I'm afraid that I make the wrong presentation, because at the end of the presentation, similar to this one I had in Germany, the result was, okay, but this is just about the density. No, not at all. Because it's not about the density, it's not about, finally it's about whole year efficiency. Is how much, let's say, how efficiently you can run this line. For example, this is foam track. This is, we keep for 1 year storage all the data in the PLC of the production. And it means that you have that, you can statistically compare, you can see if something wrong on the line. We had one line that had sometimes some small problems. We cannot understand why. Then we went to the foam track, we compare different parameters, also the most not logical one. Finally, by comparing parameters, we find out that one regulating valve was not working properly. But without foam track, we will never discover it. And we will make a lot of additional scrap and second quality or whatever. Then, okay, this is 98 inches diameter, big rolls for the thick foam. This make much higher efficiency in the product handling. Finally, you have less rolls to handle. It's easier for lamination or whatever. And then we have a lot of inline let's say inline micro perforation, inline lamination, top, bottom, different operation that usually are done offline. We do everything inline, and this also increase very much efficiency, reduce the cost of work of warehouses, and so on. Basically, I was much shorter than 14, but I hope there will be some questions that, because, okay, we come to the same, that we recycle. Yeah, one thing that maybe I forgot, and this is the main topic. Since beginning, we started, and the input to all the engineers was, we have to make the machinery around the process, not the process around the machinery, because this niche we are working in is very, very small. For big machine manufacturers, is maybe not of great interest. And usually they use machines that are optimized for other processes and is arranged the process around the machine. But we started from the process, and from the process we went to the machinery. This, I think, is also an important step that allow us to make this great savings finally. And this, we continue in this, let's say, development and new goals, and hopefully we will continue, because one thing I'm 100% sure. Today, I think on some machines we are on the top. But I'm sure that in 20 years, in 10 years, in 50 years, whatever, these machines will be very, very old-fashioned and very inefficient and very poor. Because in foam, I think we are at the beginning of the curve. We are not at the plateau. Some industries are at the plateau already. But foam production is far away from the plateau, especially with different polyolefins, and I think a lot of job has to be done in the future. Maybe not by me, but by others, no? Thank you very much for the listening, and thank you again.